Hello, calculus. Logarithmic differentiation. Let's get started. The first thing that we have to remember is the relationship between e to the x and ln x. They are inverses of each other. They undo each other. When they're right next to each other, they cancel each other out. Let's look at this first box. Here, ln is right next to e. When you see that, they cancel each other out. So the ln and the e cancel out, and we are left with that x, and that is why ln e to the x is equal to x. Same thing in the next box over. Right here, the e is right next to ln. When you see that, they cancel each other out, and you're left with what's left up there. And that is why e to the ln x is equal to x. So that helps you simplify problems to make things easier. As an example number 1, we are asked to differentiate. That means take the derivative. So you got to remember what that means. Take the derivative of y is equal to the cosine of ln e to the 7x. Okay, well that's definitely a composite function. You only see one x, but you see four functions: cosine, natural log, e, and 7x. So that would be a triple chain. But if you simplify it, look here. You've got ln and e right next to each other. So cancel them out. Then when you simplify it, it is just the cosine of what's left, the cosine of 7x. Now, that is just one chain. When we use the chain rule to take the derivative of that, hey, my outer function is cosine, my inner function is 7x. So the derivative is the derivative of the outer, the derivative of cosine is negative sine. And remember, when we take the derivative of the outer, we put in a blank set of parentheses. Inside that blank set of parentheses, we put in the inner as is. So that goes right here. 7x, and don't forget the last step of the chain rule is to multiply everything by the derivative of the inner. The derivative of 7x is 7. So then when we simplify this guy, we just always want to put that coefficient in the front. So we get negative 7 sine of 7x. So as you can see, just by simplifying that, it was a much easier derivative to take. Okay. The second box, we're not going to spend too much time with it, simply because this is distance learning. We're going to just keep it to the basics and try to shorten things up for you. But I just want you to be introduced to this. Right here, an exponential function of any base. Now, we've worked with an exponential function of any base, b to the x. You should recognize that. We have taken the derivative of b to the x. If you remember the formula, the derivative of b to the x is you rewrite the function b to the x and you multiply it by the natural log of the base. So the derivative of b to the x is b to the x ln b. Remember that? We also took the antiderivative of an exponential function of any base, b to the x. When you take the antiderivative, it's just the opposite. You rewrite the function and you divide it by the natural log of the base. So another way that you can rewrite an exponential function of any base is to use this right here. An exponential function of any base can be rewritten as e to the x ln b. So b to the x is also equal to e to the x ln b. And here's why. I can take this base right here, I'm going to highlight it in red, and I can rewrite that. Okay, I can rewrite that as e to the ln b. Why are those two things equivalent right here? Well, because right here, e and ln will cancel each other out. So it is equal to b. All right, so now the next thing we can do is we can simplify these exponents. What's the rule when you're raising one exponent to another? You multiply. So now we get e to the x l n b. The order of multiplication doesn't matter. So that is how we can kind of prove that these two things are equal to each other. Okay, Let's go down to example number 2. We know the derivative of 8 to the x. We've just followed this formula. It is equal to 8 to the x. You rewrite the function and you multiply it by the natural log of the base. Okay, now we are going to take the derivative of that same function using a procedure. We're going to go down to example number 3 now. We're going to take the derivative of this function, same function, only we're going to use logarithmic differentiation. That's our goal. And I'm just using a really easy function to show you the steps and so to kind of prove to you that this indeed here does work. Okay, so logarithmic differentiation. Here we go. The first step, you take the natural log of both sides. So we're going to put ln in front of y, ln y, and then we're going to put ln in front of 8 to the x. So that's your first step. Natural log both sides. Step 1. Check. Okay, the second step is you need to simplify exponents, and you have to remember log properties. There's nothing that we can simplify on the right, so that comes down. But there's nothing that we can simplify on the left, so that comes down. But now look at the right-hand side. In the log world, if you have an exponent, the log properties tell us that we can rewrite that and we can put that exponent out front. So ln 8 to the x using log properties can be written as x times ln 8. So that is our second step. Using log properties, simplify exponents. Okay, now we're ready for the third step. I'm going to move this up. The third step is to take the derivative of both sides. Okay, on the left, we are going to be using the chain rule, and we have to use implicit differentiation. There's a y there. So if you remember the chain rule, our outer function there is ln, and our inner function is y. And again, we have to use implicit differentiation. So the derivative of the outer, the derivative of ln x is 1 over x, so we write that as 1 over something. Then we plug in the inner as is, right downstairs, right here, so that's going to be y, that's the inner as is. Now we multiply everything by the derivative of the inner, and we just call the derivative of y, the derivative of the inner, as y prime. So we just used the chain rule and took the derivative of ln y. All right, now let's talk about the right-hand side. The right-hand side, we have to use the product rule here because we are multiplying two separate functions together, x and ln 8. Okay, so the derivative of, let's review the product rule first. The product rule is 1, remember our song, 1d2 plus 2 times d1. So it is the first function as is times the derivative of the second, plus in the middle, the second function as is times the derivative of the first. So let's tackle that one. So the first function as is x. So that's the first function. d2. Now, ln 8, there's no x here, you guys. ln x is just a constant, a number. If you punch in ln 8 on your calculator, you're just going to get a number. The derivative of any number is 0. Isn't that nice and easy? All right, now we keep going. The second function as is ln 8. And then the derivative of the first function, the derivative of x, is just 1. All right, so there you have it. 1d2 plus 2d1. All right, now we're going to go ahead and simplify that. There's nothing we can simplify on the right, so I just have 1 over y times y prime. On the left. I'm sorry, it's late. Okay, on the left, we bring that down, but I can simplify this, okay? This just goes to ln 8. This gets wiped out. This is ln 8. So the right-hand side simplifies to ln 8. Okay, now our goal is to get y prime by itself. So that's our fourth step. Get y prime by itself. All right, so this is, I'm going to draw a line so we can keep track of it. Now we're down here. To get y prime by itself, we can simply multiply both sides by y. All right, so if I multiply this side by y over 1, I have to multiply this side by y. Okay, so what happens here? These cancel out. I'm left with y prime. That's my goal. On the right, I have ln 8 times y. All right, and that gets me to my last step. Got to check off step 4. We got y prime by itself. Now the last step is we plug in y. Okay, we just plug in the original function. All right, so our original function is 8 to the x. So here we go. Y prime is equal to ln 8 times 8 to the x. And then if we kind of rewrite that and flip those around, then you can see that it worked. All right, when we take the derivative of, when we take the derivative of 8 to the x, when we take the derivative of 8 to the x, we know, following our formula way up here, okay, we can use that formula. Here it is, 8 to the x ln 8, but we used logarithmic differentiation. All right, those are the steps. That was our goal. Now we're going to try a couple more problems. Okay, calculus, example number 4, logarithmic differentiation. The first step, of course, is to ln both sides. Okay, so we are going to put ln in front of the left-hand side. So we have ln f of x. That's the same thing as if this was a y right here. And then we're going to put natural log in front of the right-hand side. So we have ln x to the third plus 4 to the cosine of x. So that's the first step. Everyone can do that. Okay, the second step, we move the exponent in front. Okay, so simplify exponents using log properties. So the left-hand side stays the same, natural log of f of x, but on the right-hand side, this exponent comes down in front. So we have the cosine of x times ln of x cubed plus 4. Okay, so that's the second step. The third step is to differentiate both sides. Differentiate means take the derivative. All right, so we need to remember what derivative rules to use. Okay, on the left side, this is going to be a chain rule because your outer function is ln and your inner function is f of x. Okay, on the right-hand side, again, this is going to be a product rule. Okay, your first function is cosine, and your second function is ln x to the third plus 4. So when we take the derivative of the first function, that's just going to be a flashcard, trig derivative. This is going to be a chain rule. Okay, so let's go to work. On the left, the derivative of ln, the derivative of the outer, is 1 over something. The inner as is f of x. And the derivative of the inner is, we're just going to use f prime of x. Okay, now on the right-hand side, we've got a product rule. So I'm going to move this over. 1 as is the cosine of x. All right. For D2, that's going to be a chain rule. Alrighty, so the chain rule is going to be 1, the derivative. Well, here, when we do this, let me just help you out here. When we do D2, okay? It's going to be a chain rule. The outer is ln, the inner is x cubed plus 4. Okay, so we go to work. The derivative of ln is 1 over something. The inner as is, we plug in downstairs, right here is x cubed plus 4. And now we multiply everything by the derivative of the inner. The derivative of x cubed is 3x squared. And of course, the derivative of 4 is 0, so plus 0. So I'm going to put this over 1. All right, so this right here is 1. This whole thing here is d2. Okay, now let's keep going. Now we come back with the second function as is. So we have ln x to the third plus 4. So that is 2 as is. And now for d1, we just need the derivative of the cosine. And we know that the derivative of the cosine is negative sine of x. So there we have it. There is a mouthful. Again, on the left-hand side, the chain rule. 1 over something is the derivative of the outer. F of x is the inner as is. This is the derivative of the inner. On the right, we did the product rule. 1 d2 plus 2 d1. Okay, so now let's try to simplify this over here. Let's clean that up a little bit. So this left-hand side is going to stay the same. 1 over f of x times f prime of x. But on the right, this whole thing here, I can rewrite that as 1 fraction. So I'm going to leave the cosine of x alone, but I'm going to write this right here as 1 fraction. So that's going to be on top 3x squared, and on the bottom x cubed plus 4. Okay, so there we go. Now on the right hand side, there's really nothing to simplify other than we want to get this negative out front. So this changes to a negative. We have minus sine of x ln x to the third plus 4. All right, so there we go. Now, the next thing we're going to do is we are going to, so I'm just going to write down what we did here. We just simplified the right side. Okay, now our next step in logarithmic differentiation is to get y prime, or excuse me, get f prime of x in this case by itself. Okay, so we're going to multiply each side by f of x. Okay, if I multiply this by f of x, the f of x's are going to cancel. So here's, I'm just going to show you what I'm doing in green. I'm multiplying this whole side by, by f of x. And I'm just going to put it over 1 because then you can see that those do cancel out. All right, so on the left-hand side, f prime of x is left, and that was our goal, to get that by itself. Now on the right-hand side, I have to multiply the whole thing by f of x. And then I bring that whole thing down. Cosine of x times 3x squared all over x cubed plus 4 minus sine of x ln, oops, you got to see that, I got to see it, x cubed plus 4. Okay, so the only thing I did there is I multiplied this whole side, and I'm going to show it to you in green again. I multiplied this whole side by f of x because I did it over here. All right, now the last step is to plug in the original function right here for f of x. Okay, so, ta-da! The derivative, f prime of x, is equal to f of x. What is f of x equal to? Well, f of x is equal to x to the third plus 4 all to the cosine of x. So there it is. And then we bring this whole big monstrosity down. So it's messy. So we just bring it along. Cosine of x times 3x squared over x to the third plus 4 minus the sine of x times ln x to the third plus 4. Ta-da! There it is. Logarithmic differentiation. A lot of writing, a lot of steps. Okay, I hope that made sense. Please try example number 5 on your own and check the solutions. The solutions will be posted on the website. All right. Catch you later, calculus.